is take a segment, a couple inches or so long, and if we're going to do something that's called the perpendicular bisector. Now, in years past, we've done the perpendicular bisector, and we've worked it in terms of a progression on progression sheets. Obviously, we're not doing progression sheets for this. We're not doing any proofs. You don't have to worry about that. But what I want you guys to remember is some of the terminology. We did stuff about perpendicular, and we did stuff about segment bisector. If I have a segment bisector, what does it do to the segment? It cuts it in half. You get how many congruent pieces then? 2. So let's figure out a good spot that might be about halfway, and we'll just call it here-ish. And we're just going to mark our diagram. So just by vocabulary-wise, I can say that that's been bisected. But now what I have to do is draw the perpendicular. When something's perpendicular, what does it create? The 90-degree angles, yeah, the upside-down T here. So if I do this, and just make one right angle. Do I have to put 2? You don't have to. If you do, is it the end of the world? No. More often than not, you'll just see it with 1. So this diagram here is what a perpendicular bisector looks like. Okay? It's nothing crazy. It's fairly simple to look at. But the weird, I don't want to say weirdness, but the important things come in with the following. What I want you guys to do is take anywhere on that vertical part. I'm assuming most of you guys drew that vertically. Anywhere on that vertical, put a dot. And then I want you to connect the endpoints of the segment. And for the time being, don't pay attention to the line above the dot. Okay? Don't pay attention to the line above the dot. If you look at this, don't you have 2 triangles here? Are they congruent? What do we have to mark? The reflexive. I got to mark the reflexive here. Okay? If I mark the reflexive there, it's congruent by side angle side. Very good. Now, those blue legs that I drew in there, what can I say about those then? They're congruent because of what? Yeah. Remember that whole thing that corresponding parts, congruent triangles are congruent? So if I put any dot on that perpendicular bisector, well, let me try this in. What if I move the dot up here? Still give me the same deal, isn't it? I still draw it over here, still draw it to here. These are still, this is still the reflexive part, isn't it? It's still side angle side no matter what there, which means that these are still going to have to be congruent. Sometimes when you get more than 3 tick marks, people use B's, or they'll use like a circle or something that just doesn't look as crazy as going, you know. Yeah, it starts getting messy after a while. Okay, so that's one of the things we'll start to see. Same deal if I put it right here, really low. That's still reflexive. It's still side angle side. So basically what I'm getting at here is that if you are on the perpendicular bisector, you are equidistant. I just write equal this to the endpoints of a segment. It's kind of long-winded for just basically CPCTC after you have side angle side. What kind of triangles, what kind of triangle did the perpendicular bisector make? Isosceles, yeah. The perpendicular bisector, if you have one of those, it always creates congruent legs coming down from it, which makes it automatically at least isosceles. Could it make an equilateral one? Sure, absolutely. Don't worry about that one now. Right. It's very, very, very straightforward. Now, what we've said, excuse me, one of the things that we do is, I don't think we'll have time to get too far into it now, but just for fun, how many sides does a triangle have? How many midpoints can a triangle have? How many mid-segments can it have? How many angle bisectors can it have? 3. How many perpendicular bisectors can it have? 3. So what's going to happen here is eventually we're going to have all these different things coming through. I'm not going to be really getting so much into it today, but we're going to have all these parts that do this. They all run into at one spot. There's going to be certain rules that happen when things run into each other. And that's what we probably won't get to that today, but I just wanted you guys to see that aside from the difference when we had mid-segments don't run into each other. Perpendicular bisectors will, angle bisectors will, and altitudes and medians will. It just depends on vocabulary. Just wanted to show that. This is this. Which means, oh no, really, really, really hard algebra. Whew. I know. I ask a lot of you. I'm sorry. We have these things called expectations. As low as they may be, I still have them. Sorry. So, like I was saying, we have this thing called the perpendicular bisector. No matter what, if you are on the perpendicular bisector, you are always equidistant to the endpoints. Always, always, always. Because this is reflexive. It always works. Okay? Which means we'll have some algebra just like this. When you look at the diagram, first thing you should ask yourself, is BD perpendicular bisector? Yeah. Because there's a right angle and it's got the little tick marks for the segments. People were asking this earlier. Do you have to have right angles on both sides? I'm sorry. Does it have to be shown that there's right angles on both sides? It's very common for it just to have the one angle, just because it's cleaner. That's really all it is. There's no rhyme or reason. Sometimes you'll see them draw in with 2, sometimes you won't. It's not a big deal. If you draw it in, that's fine. Again, it's not a big deal. What would you have to do here algebraically? Pace yourself. It's nice when math becomes a little easier, isn't it? Yeah. This is also a really good example to show you guys because this is the style of an algebra problem that you guys tend to make a dumb mistake with. Obviously, I heard you say subtract the 6x, but a lot of times when we do this, more often than not, we like to say pick on the little guy. So if you pick on the little guy here, what would happen if I moved the 4x? What would I get on the left side? A 0. Okay. A lot of times people forget that. So I like your idea, move the 6x, that way I don't have to deal with zeros. But what do I have here now? What's on the other side? You got to remember that this was a negative value to drop. That's usually where people will mess up. That it was negative. Right? And doing this maybe once or twice is where people screw up. And then you get 5. Again, very, 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 very straightforward. But what can you do to make sure you didn't done goof? All right, so pace yourself again. I know. 4 times 5. Okay. 6 times 5. 30. Subtract 10. 20. Okay. Now you weren't saying anything. I was worried about you. I know it was a lot. Okay. I know it was a lot. That's what I meant. I knew it was a lot. You were really quiet. And I got really nervous. And again, you just matter of throwing it back in here and you get 20. Okay. I may be just a little bit oversimplifying it for you. I don't know if you noticed that. Sometimes it's hard to tell with the sarcasm. one thing to remember when we're dealing with a lot of this stuff, do you see anything in here about any angle measures? Except for the 90. There's really no way for us to start working through and solving for any angles because we don't know enough. There's not enough here for us to be able to figure this out at all. What do you have to do algebraically here? Again, it's just a matter of just setting them equal to each other. Okay. Variables on both sides of the equation. This time, since they're both positive, I'm just going to pick up, or this time, if I'm not have to worry about having a 0 on either side, I'm going to do both steps at once. Subtract the 3x, add the 7. Then you get 3. Okay. Substituting back in, what's 3 times 3? Subtract 1. 5 times 3, subtract 7. Woohoo. What? Are you crazy? In case you didn't realize that. Okay, angle bisectors. That was tough. This is another thing that we've actually dealt quite a bit with. I know you don't have your progression sheets, and I'm going to get all that stuff back to you guys hopefully tomorrow because we'll have time, a little bit more time. I finally had the last person that took the test, so that's awesome. When you had an angle bisector, what did it do? Yeah, it took an angle and cut it into 2 smaller equal ones. Okay, and when we did that, we knew that we could draw it in. And we would make tick marks. You okay with that? Now, just like we did a minute ago with the perpendicular bisector, I told you guys to pick any point on it. Do the same thing. Put a dot somewhere on that angle bisector. How many of you guys have ever used a tape measure? A tape measure? A tape measure. An actual thing you measure stuff with. A tape measure. I know. Anyway, if you were to measure a distance, if I wanted to measure to the wall from where I'm standing, I have a bunch of different ways to measure to it. What's the right way to measure to it? They're all straight knucklehead. Which way is the correct way? Which is the shortest way? Shortest distance between 2 points, your right is straight. But as you measure straight distance, you're measuring perpendicular distance. I'm sure many of you guys have had your parents say, stand up straight, don't slouch. So they measure your height, you're completely perpendicular, not punching over. So you form that right angle. So what happens here is if you draw segments that are perpendicular back to the side of the angle, like this and this. Does everybody see you have 2 triangles? You're squinting like crazy. Trace it. There's 1. There's the other. Are those 2 triangles congruent? What else? What else do I have to mark? Reflexive. These 2 triangles are congruent because of what? Whoa, I've heard side angle, angle. I've heard angle side. What? It's angle, angle. No ass. There's no ass. That's right. It's angle, angle, side. Same thing, yeah. But we usually just say it as angle, angle, side. That's just common. Okay. What happens here is you get what's called angle, angle, side. Again, we've done all of the congruency stuff before. We know that we've got a right angle, we've got another angle, then we've got the side. So if those, if you're on that angle bisector and you're equidistant to the sides, excuse me, you're perpendicular to the sides, that means you have to be equidistant. Okay? So when you're an angle bisector, it's two things. Whereas when we were perpendicular bisector, always said we were equidistant to the sides of the segment. Angle bisector has two parts going for it. If on angle bisector, one, you're perpendicular to the sides, and two, you're equidistant to the sides. And again, this all works because of corresponding parts. This is one of those reasons why we show the corresponding parts, so that way now when we get into all these other little bits and pieces of segments, we can do, actually we can probably use Pythagorean theorem because we have perpendicular. We can do a bunch of other algebra stuff because we know what parts are equal to each other. It works cleanly. It's just an extension, honestly, this whole section, this chapter, is one step on top of an algebra problem. Just knowing the geometry vocab would do something. And that's what all this is. And you read the vocab to use the right algebra set. Okay? So, if you're on the angle bisector, you have to be, well, obviously it has to bisect an angle, but those two tick marks come into play. You're going to be perpendicular to the sides, and you're equidistant. That's what happens. Which means, algebra. That works better. I always forget if I'm on a pin or not as I go into it. So as we get going into this, is NR an angle bisector? And the reason we know that is why? Two angles with the tick marks. Okay. We also know that those two guys are perpendicular to the sides, which means you can do angle, angle, side. Yes, sir. There has to be. Remember, that's the definition. Because if you go back to what I was saying, if you're an angle bisector, if you're on it, you have to be perpendicular to the sides, and you're equidistant to the sides. That's part of the definition. So just by looking at it and falling back into the idea of why it works, we know the two triangles have to be congruent because angle, angle, side, because there's no
S. No S.
hey, you're like sleeping on me there.
I'm slacking. I think about it all the time. You gotta make sure.
Call him the math mascot.
Let's go.
No, what we need to do, we gotta make like a sandwich board, placard for him.
Yeah.
So you can walk around just yelling, no ass, no ass. Just walking in the hallways one day.
I'm making a t-shirt for all of us.
No S.
Please put the hyphens in it, okay? Do that at least if you're making a t-shirt. Thank you. Anyway, That has to work. Those two segments have to be congruent because of the corresponding parts. Okay. Subtract the 2x, and like we were saying, this math today is really, really, really easy. Please go ahead. What was that? Which way do I move? I just moved the 2x. Pick on the little guy. You get 35, and obviously, Dylan here also. The beginning of this stuff is really, really quick and painless as far as how a lot of the setups are going to go. It's when we start talking about the larger vocab words, when we get into those tomorrow, that's when you have to be careful about what's what. That's when you have to understand if you have an in-center, you're dealing with angle bisectors. If you're dealing with the other one, you're dealing with the other thing. There's like 4 different weird names that we have to keep straight. If we keep those parts straight, then we understand what parts to set equal. Anyway, so that's when things get a little. It's not that the math's gonna be tough. Just making sure we set it up. I like her accent. I don't know if you noticed that.
No, I think that's
It, how many angles are in a triangle? Which means how many angle bisectors do we have? We have 3 of them as well. A lot more when we start drawing these things in. As you get into it, as you get going into this one, it's not difficult at all. As I hope you guys understand. It has to be. Yep. They have to be. They have to be. Remember, as you're going through it, the reason that this works, go back to when we were going through all of our congruent triangles. We always had to mark stuff to show that they would work. If you remember, you've got 2 angles. You put a side in, you get angle, angle, side. Which means all the parts that have to be congruent, corresponding parts, I should say. That's where you get your 6x and 3, is 4x and 9. Subtract the 4x, subtract the 3 at the same time. And then it's just a matter of putting it back to the right spot. Well, I'm sorry, what was that? Okay, I thought you said 23. I was like, want to make sure you add that to there. Yep, and you just multiply back together. 12 and 9 is what, 21? Now, I drew this kind of quickly off to the side. Anyway, I drew this off to the side real quick, and just to kind of show you guys like what we've been talking about. On the right board, we had the mid segments. The mid segments, all three of them didn't intersect each other. Perpendicular bisectors can intersect each other. Angle bisectors will intersect each other. As we get going on and on, these points have names. These points have certain things that happen then inside the triangle. That's where the math part, it's not that it's difficult, obviously you can see the algebra, really easy, but it's keeping straight some of the vocab that we'll have. Like I said, there's going to be about 4 different vocabulary terms, and as you start picking them together, we'll come up with easy ways to remember them. Just so you know, it's not always this straightforward. Show you the other example I had. Work. Okay. With these guys, it depends on the type of triangle. They're always going to intersect, but sometimes they're in the triangle, sometimes they're out of the triangle. We'll get into it. It is really easy if you can keep 4 vocab terms straight. You're going to be fine. My question here is, does my question here is, does BD ray bisect the angle ABC y and or y not? What say you?
I yes, because the 2 sides that are coming off of the angle bisector are
Okay.
like
Does it say it's perpendicular? Can you assume that it's perpendicular?
yes.
What is there no in math?
Wait, flashlight said there's an
Whoa. 2 things happen. Perpendicular, equidistant. Right. Doesn't say that it's perpendicular, does it? Now, this is a good example here because they draw this to make it look like it works. I should do that now. Try that again. It can be the same distance because you can still have going out either direction, but it doesn't necessarily mean that it's the same angle. That's where it's getting to. Okay. So that would be a no because it doesn't show that. Okay. Yeah, exactly. It's very common. This is a very common style question. Also, if you start marking it out, you know you have that, but there is no way to know anything else. You can't mark anything else on the diagram. You can't mark anything else. That's a very common style where you have to be both parts. Now, I I've got a couple of these for you. They shouldn't take very long at all. These are pretty quick. I'm going to skip over a couple of the types of problems because we did not get to the vocabulary earlier in the day. So I want to make sure that we get to the vocabulary, all of us, tomorrow. So as this goes through, I'll show you guys what I wanted to talk about here. Why bother counting? So there's two sides. There's two sides. There's one side says 5.2, the other one says 5.3. And one of the reasons we chose to go this route with this is because the newer textbook basically does proofs with all this. We're not doing any proofs with any of this. So I wanted to switch back to some algebra problems. Okay? So on the 5.2 side, just go up through 12. Which basically means that that bottom picture, don't worry about it. Okay? There's information on that bottom picture that we don't know yet. We'll get to it tomorrow. We just didn't have enough time. We probably could squeeze it, but it wasn't worth the rush. On the 5.3 side, same thing. Just go through 12. Okay. Well, right now, those bottom two, we don't know what it means. So I'm not worried about it. We'll pick those up tomorrow with those definitions and how they all work. And what is it? What are you looking at when you see that curve? Talk about it tomorrow. Okay. But for the most part, this stuff should be really quick. A quick hint on 5.2. A lot of people tend to ask about what do you do on this problem with all those questions. What I would always do is use the definition that they gave you. It said that EH was the perpendicular bisector of FB. So I would go to my diagram and mark those two are the same. I know that FG and GD are the same because they already have tick marks. And then I also know that ED and EF have to be the same because what are they on? They're on the perpendicular bisector. So that means you can solve for X and Y separately to figure out what FH is. Okay? A lot of times people freak out about that one because they don't remember what things mean. So I want to reiterate that for you. This really should take more than 15 minutes tops. Please get started. Maybe you should be able to most of them walk out of here. Can't count, can I? Why should I start learning now? Yeah, then we'll get into the idea of what's called that in-center tomorrow. It's easy, it's just ran out of time to explain all of it. That happens. Like I just want to get out of his way.